Okay, so what we're going to be talking about today is direct and inverse variation. Okay, so that's the lesson for today. It's a little bit different from what we've been doing. It's not difficult, but you have to remember 2 steps. Think you can remember 2 steps? Okay, I hope so. All right, next page. Okay, so direct variation is when 2 variables are directly related if the ratio of their values always remains the same. So basically what I need you to take from this is the formula. Direct variation equals y equals k times, sorry, my brain is foggy today, y equals k times x, okay? So when you see direct variation, when you see the word varies directly, you have to automatically write down the equation y equals k times x. Think you can do that? Okay. So k, this value of k right here, that value of k, and you need to write this down, that value of k stands for the constant of variation. Okay, k stands for constant of variation. Are you in, honey? Okay. Constant of variation. What does the word constant mean? Yeah, it stays the same, doesn't change, okay? So that's going to be your fixed variable. It's the variable that does not change. The value does not change, okay? All right, so let's look at what direct variation looks like graphically. What is it? This isn't a trick question. What is that? It's a line. It's linear, right? So f of 1 of x equals k times x, right? What does k stand for? If you're thinking in terms of a line, what does k stand for? Yeah, which is what? If I were thinking about this as an equation of a line, the slope, okay? K stands for the slope in this case. So how something changes, and it's that constant value. All right, so what's going to happen as my value of k increases? Good. Slope becomes steeper, right? It's a faster increase. Make sense? How about when k decreases? Less steep. Okay, it doesn't change as fast. It's a more of a gradual change. How about when k is 0? Struggling. What happens when k is 0? There's no slope, so where's my line? Yeah, it's the x-axis, okay? So if the constant of variation is 0, the whole function is 0. How about if it's negative? Slope will be negative, right? Okay, so things in real life that show a direct variation. The more it rains, the higher the level of the lake will be. The more you study, the better grade that you'll get. Okay, those things are directly related. The more fast food you eat, the higher your body mass index. Okay, so all those things are directly related. All right, so what happens to the value of y as x increases? What happens to the value of x? What happens to the value of y as x decreases? So as x increases, y increases. As x decreases, y decreases. Okay, they're directly related. As x increases, y increases. As x decreases, y decreases. Okay. Yep. So as x increases, y increases. As x decreases, y decreases. It's always the case for direct variation, not for inverse, which we're going to talk about in a couple minutes. Okay. Nope, I don't care how you word it, just as long as you understand it. Are we good? Okay, so what did you notice about the y-intercept? Yeah, it's 0. Does it change? No, so the y-intercept isn't going to change. Okay, so an example of direct variation is how much an hourly employee gets paid, his or her total paycheck, is equal to a certain wage multiplied by the number of hours. How many of you have jobs? One of you. Okay, so how can you go about getting a higher paycheck? If you want more money per week, what do you have to do in order to get more money per week? No, you don't. You work in McDonald's, you're not getting a raise. Well, I'm just saying. You could work anywhere. You work no. What? More hours, right? She doesn't have a job and she knew that one. Okay, so if you want to get paid more, you have to work more. Okay, so that's direct variation. Oh, by your wage? No, sorry. I should have been more specific. Okay, so P equals W times H. Which letter represents your constant of variation? Which thing there does not change? W, good. Your wage does not change. How much you earn per hour is your fixed value. Okay. All right, so I want you to rewrite that wage function as if you're being paid $6.50 per hour. So if you need to go back and peek at what that equation was, right? What was it? P, good, P equals W times H. I want you to rewrite it using the value of $6.50 per hour. What's the matter? Okay, who's got it for me? Times H. Okay. You okay with that? Try the next one. Should take you 10 seconds. I'm counting in my head. What'd you get, Alyssa? Good. P equals 9 times H. Oh, that's real. Okay, how you feeling? Any problems? Good? All right, so let's move on. Inverse variation. This is the one that is tested much more often. I doubt that you see a direct variation. I know you will see an inverse variation. Okay? So, inverse variation, two variables are indirectly related if the product of their values always remains the same. So whenever you see inversely related, the first thing you're going to write down is y equals k over x. So y equals k over x. K still stands for constant of variation. Good, the variable that doesn't change, constant of variation. Okay, so this graph looks a little bit different. I want you to take that slider up here. Right now it's on 0, okay, which would make sense because 0 divided by anything is 0. Okay, so take that slider. Do you guys know how to grab something? Okay, control click or hold down until the hand closes. And move that slider back and forth. It looks a little bit different, right? Does anybody know what the name of this type of graph is? It starts with an H. Good, hyperbola. Hyperbola. Hyperbole is something from English. Okay. All right, so this is a hyperbola, right? So I want you to pay attention as k gets larger, your constant of variation gets larger. How is this graph changing? It's getting further away from what? From the origin. Okay. When with 0, we know that it disappears because the whole function becomes 0. What happens when we're negative? It switches sides. Give me another word. Quadrants. Good. So if it's positive, what quadrants are we in? 1 and 3. Yep. And negative? 2 and 4. We okay? Any problems? Odds and ends, right. Okay, so what happens to the value of y as x increases? So what happens to y as x increases? Y decreases, because we're talking about inverse variation now, right? So as x increases, y decreases. As X decreases, Y increases. So we're dealing with inverses here, opposites, right? So as X increases, Y decreases. As X decreases, Y increases. Okay. And what quadrants does the graph appear when K is positive? 1 and 3. Good. Negative? 2 and 4. So positive, 1 and 3, negative, 2 and 4. We okay so far? All right, so what value of K does it disappear at? 0. K equals 0, it disappears. Why? Because it makes the whole function 0. You can skip 3.6. Go to 4.1. I want to start getting into some sample problems. All right. For a salaried employee, the amount that he or she earns per hour is inversely related to the number of hours she works. He or she earns a fixed amount per week, regardless of how many hours he or she works. So I'm a salaried employee, right? Am I better off working less hours per week or more? Less. Why? Right, I get paid the same either way. Okay, my paycheck isn't going to go up because I stayed 60 hours instead of 40 hours. Understand? Okay, so the amount an employee earns per hour is equal to the amount earned per week divided by the number of hours worked. So if I wanted to figure out how much I was taking home per hour, I'd have to take my salary and I'd have to divide it by the number of hours that I put in per week. Does that make sense to you guys? Okay. All right, so we're dealing with the equation R, meaning rate, equals S over H, salary over number of hours. In the equation R equals S over H, which letter represents the constant of variation? S, right. My salary is not going to change, so that's my constant. Okay, so I want you to rewrite the rate function if the employee is being paid $900 per week. What'd you get? Good. Any problems with that, guys? Do we need to do the next one? All right, I'd like to get into some real problems. So, okay, you got your notebooks out, right? If you don't, please do. No. I think the actual problems are more important, so we're going to try these. Okay, so like I said earlier, these types of problems are two-step problems, okay? Generally speaking, they do not tell you what the constant of variation is. You have to find that information, all right? So inverse and direct variation problems are going to be two-step problems. The first step is going to be to find the constant of variation. And then the second step is going to find your missing variable. All right, so first thing you're going to do is read the problem, obviously. Variable m varies directly with p. If m equals 75 and p equals 10, find m when p is 16. So here's our first step. Varies directly, good. Which means I'm automatically going to write down what? How about y equals k times x? Okay. And he just took the step that I'm going to use next, and this is an important step. Okay, they're using P and M. So you have to use P and M. Does it matter what I choose to be P and choose to be M? No. Okay, so let's say M equals PX. Sorry, KP. Okay, so I'm replacing y and x with the variables that they're choosing for me. Okay. My next step is to set up my pairs. I'm going to have two pairs. Okay, my first pair is going to be what they're giving me. So when m is 75, p is 10. Okay, that's a pair, right? And then m, do we know m? We don't know when p is 16. So do you see how they're paired up? Okay, do you understand how I got the pairs? Okay, so here's step one. Find k. Okay, I have to find k using the original information they gave me, which is, yeah, okay. So I've got my equation. M is 75 and p is 10. We good? Now what? Divide. So k is 7.5. Okay, so I took the original information they gave me and I found my value of k. We good? Okay, so step two, find missing value, which in this case is what? M, right? All right, so do I know m? No, so I'm going to write m equals. Do I know k? Sure, 7.5, we just found that. And do I know p? 16. Good. Okay. M equals 120. Good. Done. What do you think? Not bad. You gotta follow those steps, okay? You have to have that two-step. Find k first, find missing variable. It'll say directly or inversely. This one is directly, so we used a direct equation. Okay, we're going to do an inverse one next. Are you guys ready for me to move this? Okay, r varies inversely with the variable t. If r is 168 when t is 24, find r when t is 30. Keyword, inversely. Equation. Good. Y equals k over x. Okay, are those the variables they're using? Okay, what's the variables they're using? Does it matter where they go? As long as you're not putting it in for k, all right? So r equals k over t. Okay? Okay, step one, we got to find what? Okay, so before we do that, we need to set up our pairs. All right, so r and t. What was my original r? Good, my original t. Good. R? We don't know. T? Good. Okay, so we got our pairs set up. We know our equation. First step, find k. So r equals k over t is the formula we're using. We know r, 168. We know t, 24. How do I find k? Yeah, cross multiply. And what do we get? I'm sorry? 4032. Good. We okay with that? Okay, step two. Do I know r? No. Do I know k? Do I know t? What do I do? Divide. Go ahead. I'm not doing this for you. You're more than capable to press buttons. Good. What do you think? Not bad, right? Okie dokie. Varies jointly would be directly, yeah. Can I make this go away? All right, so I want you to try number 4. Okay, I'm going to pause the video here, try it at home, and then come back when you're ready. All right, the volume V of a gas varies inversely as the pressure P in a container. The volume of gas is 200 cc's when the pressure is 1.6 liters per square centimeter. Find the volume to the nearest tenth when the pressure is 2.8 liters per square centimeter. Keyword. Equation. Good. Am I using Y and K? What are we using? Good. V equals K over P. Are we all okay with that? Okay. So make our pairs. What's V to start? 200, yep. And P? Good. V and P. Good. Great. Nice job, guys. Okay, so we're going to start by finding K. So 200 equals K over 1.6. And what is it? Good. We all right with that? Everybody got 320? Okay. And then 320 is our K to start. We don't know V, and we know P. So what did we get for V? 114.3 cc's. Great. How did we do? Is this easy stuff? Just got to remember those 2 steps, right? Okay. Okay, so your homework tonight is actually in your calculator. Lesson 5 homework. There are some questions in there about functions. You can skip those because I know you guys know functions. Please just do the ones with variation. Okay, so it's probably like 6 problems. Think you can handle that? Okie dokie. Thanks, guys.